A major limitation of the linked file allocation scheme is regarding the direct access of any particular file block. Suppose we need to directly access the third block of the file list. For that, we should first access the directory, get the address of the first block. Then we should move to the disk and access the block from that location and read the address of the second block. Then we should go to the location of the second block, read the block and read the address of the third block from that block. Then we can go to the third block and can access the third block. So for the direct access of any particular block, we should access all the previous disk blocks. And depending on the location of these disk blocks, a lot of disk head seeks may be required. In this video, we shall see how to overcome the limitation of the linked allocation by using a variation of the linked allocation scheme with the file allocation table. Here, similar to the previous implementation, the file is allocated with non-contiguous set of disk blocks. And a table named File Allocation Table is kept on the disk. For every disk block, there will be an entry in the File Allocation Table with the block address as the index to the table. And the directory entry points to the address of the first file block. This address will now index into the file allocation table, which contains the disk block address of the next file block. Now moving to index 8, the value is -1, which shows this is the end of the file, no more file blocks. Now consider this file. The directory entry points to the address of the first file block, which is 12. Now this value indexed into the file allocation table, which contains the address of the next block. Now coming to index 14, it will contain the address of the next block, which is 7. And the index 7 is having a value -1, which shows this is the end of the file. Now consider one more file. The starting disk block address is 9, which shows the first file block is located in the disk block 9. Now 9 will act as an index into the file allocation table, which contains the address of the next file block. The address of the second file block is 0. Now go to index 0. It contains the address of the next file block. It shows the next file block is in the location 2. Again go to index 2. It will contain the address of the last file block. The last file block is in the disk block address 5. Now coming to index 5, the value is -1, which shows this is the end of the file. And a value of 0 shows that those blocks are unused. Thus the directory points to the address of the first block, and remaining all information about the chain or the linked list is maintained in the file allocation table. Whenever the disk is in use, the FAT or file allocation table is read into the main memory. Now what are the advantages of this method? Suppose we need to directly access any file block. Since FAT is kept in the main memory, we can find the location of that block from the directory and the file allocation table itself. And we need to use the disk only for accessing that particular block. No need to access any previous disk block. This will reduce the number of disk head seeks. Hence, this allocation method is suitable for both the sequential access as well as the direct access of any file block. And the next advantage is that the entire disk block is reserved for keeping the file data, unlike the previous method. In the previous method, a portion of the disk block is reserved for the pointer. Here, the entire disk block is reserved for the file data. Also, there is no chance for external fragmentation, no need of compaction, and the file can continue to grow on as long as free blocks are available and the size declaration problem is resolved. And the disadvantage of this method is the size of the file allocation table. Depending on the size of the disk and the number of disk blocks, the file allocation table may require large number of entries. Hence, the size of the file allocation table is a problem.